Dzień dobry. Nazywam się Książę Canuma. I'm just kidding. Come on, guys. So, so today we're going to talk about RAGs, but I wanted to ask you. Oh, this thing is not working. It's okay. I'll use the clickers. It's not working, but it's fine. No, it's fine. It's fine. Keyboard?
Okay, if you feel comfortable with that.
Keyboard is also not working.
So we cannot start. Okay.
Okay, cool. Does it work now?
Maybe now?
Okay, awesome.
Okay, everything works.
Awesome. You see, the speech is so good that the gods are like, nah, he can't do it. So the first thing I'm gonna ask you guys is, what is the difference, or what do they have in common? A maluk and a llama. Who can guess it? Okay, go ahead. A vehicle? Interesting. Watch closely and learn. So this is the agenda for today. First, I'm going to start why open source ML. Then we're going to talk about why SLMs are the most important architecture or type of model this year. Then I'm going to talk about on-device inference and give you some really cool examples of projects that I've been involved with that show a lot of potential. Then I'm going to take you from rags to riches. I know all of you here know about RAG, but you haven't yet discovered the riches in RAG. So I'm going to help you do just that. And then I'm going to talk about some of the machine learning experiments, open source machine learning experiments I'm running and documenting as I go. All right, so who am I and why do I have the authority to be here? So my name is Prince, and I have, over the course of a decade now, been contributing to all of these projects. Previously worked at Neptune AI, and right now the current reigning king of MLX. And I'm going to tell you about MLX in a few. So why open source? I remember earlier this year, I gave a talk where I showed that Hugging Face had about 500,000 models. But actually, I was wrong by 500,000 because a week after that, they announced that they have 1 million models on their platform. Of course, around 400,000 of those are private models that companies have hosted on their platform, but you have about 500,000 open source models. Then on top of that, it has now 162,000 data sets. Imagine this, my last talk, it only had 128. So it grew really fast and really quickly. And there are pretty much around 3 things that you should think about when it comes to open source. The first one is that it's easily to customize. Yes, you do have customization with hosted APIs, but with an open source model, you can go beyond that. On top of that, you control the data. Your customer's data, your company's data is all yours. You know what's happening to it at all times. And finally, it's scalable, not because of your own efforts, but because of the effort of an entire community. We are talking about millions of individuals contributing to open source every day and also pretty much experimenting with it. So you will benefit from that growth and all of that progress that's made beyond your company. Probably you don't have the funding to do it, and even if you did, you wouldn't be able to compete with open source. Now, these are some of the metrics that I've been tracking since the beginning of the year. My last talk, I had around 13 models, and this was less than 2 months ago. Now I have over 200 models uploaded to Hugging Face. I have around 10,000 downloads across all of those models, more than 5,000 likes, and the top 10 best models on MLX are models that I managed to port or created. Now, 2024 is the year of small language models. Who can tell me why? Anyone? They're specialized. That's a good one. Performance, yes. Another one? Price. Oh, great. You guys really know this thing. So, you know the saying, bigger is better? Well, not always. And in this case, it's actually reasonable to go smaller. Now, when it comes to the importance of small language models, here's why it is crucial for you to leverage this type of models. On-device inference. Why do you need on-device inference? What are the benefits of on-device inference if you have a product or you also develop this kind of models? Anyone can tell me? Privacy, that's a really important one. Anyone else? Speed, yes. Another one? Cost, exactly. I want to zone in or drill into cost. Why is this important? All of the compute that you would have to host with servers and etc. is now going to the client side, meaning you literally have zero server costs. Of course, you might have a website and so on, but now you don't have to pretty much rent or buy specialized hardware to run these models in the cloud. Because I believe that majority of the use cases, at least for the normal average company, you don't need highly specialized model, like a highly pretty much scalable model. You just need a good enough model that can run on device, because majority of the use cases can fit within a 7 to at most 13 to 20 billion parameter range. And nowadays, people have highly specialized hardware, meaning your MacBooks, your Intel PCs, that can run these models at speeds greater than the ones of hosted APIs. Thus, that's why I'm super bullish on MLX. So what is MLX, Prince? Well, MLX is an array framework for pretty much research on Apple silicon developed by Apple Machine Learning Research. And here's a great example of why this is important. So when Llama 3 came out, I pretty much ported it to MLX. That's why you see my name here. I ported it to MLX, which was one of the creators is Anui, and we pretty much collaborate a lot. And within an hour of me porting this model to MLX, someone had Llama 3, 8 billion parameters running on an iPhone 15 Pro at 16 tokens per second. That's faster than you probably can even read these things. Of course, you might want faster speeds, but just stop and think about this for a minute. Llama 3, 8 billion parameters running on an iPhone. Imagine what you can do with a fully fledged machine like a MacBook. And this brings me to another project that I'm super passionate about, and I happen to have been lucky enough to be the creator of. This is MLX VLM. So it's a package, a Python package that you can install today, right now, to run vision language models on your Apple device. Of course, it has to be an Apple Silicon, so M series of models, M series of laptops. But this type of framework here that I developed allows you to run, for example, this is an example that I created with a model called IDefX2, a model created by Hugging Face. And you can see that I just sent an image and asked to explain what this image is. And it says, in this image, we can see a group of people standing on the ground. At least it got that right. It's not standing on the moon. So why did I develop MLX VLM? I noticed that MLX is still super young. It's only about 6 months, and there's a lot to be built. So if you want to contribute, today is the day that you can start. There are a lot of other really, really cool models that are running right now on device, and hopefully this video runs. Let's see. So here's an example of OCR running on device. That's how quick it was. That's all it took, and you can see the text on the image, and you can see the text here. It got even the ellipsis right. So that's the power of MLX and some of the things you can do. Okay, it's now stuck. Okay, let me try and, okay. All right, so now you learned about on-device inference. You learned about the power of small language models. How does this translate into RAG? Why is this important to RAG? So today, you're going to go from rags to true riches. Okay. All right. Anyways, I'm just going to use the things here, the mouse. All right. So here's a high-level overview. I don't want to bore you with the details. I know you already seen talks about RAG. Who here doesn't know about RAG? Okay. So at the high level, you have all of this. You have all of this data, private or public data. It comes in different formats. In machine learning, we call these modalities. So you have text, audio, images, and you process this data by splitting it into, let's say if it's text, you split it into chunks. If it's images, you pretty much just process them in a batch. Okay, give us a second. Magda is working her magic here.
Maybe not.
And with that, you have a embedding model. So what does embedding model do? It takes whatever data you have, text, image, and so on, and transforms it into the vector space, which is what machine learning models understand. They understand numbers. So we use an embedding model. It gives you just an array. Okay, fantastic. It gives you an array of numbers, and you store those array of numbers alongside the data that it corresponds to in a database. You can think about this as a normal SQL database. Of course, you now have what you call vector databases, but they're just pretty much glorified SQL databases. And within that, you have an interface, let's say your mobile application or a PC application that the user interacts. It sends a query, like a question. For example, if you have text, it's the news. You want to know what's happening in Poland today. The model, then the system pretty much takes this input, converts it into the vector space and calculates the distance between the question you ask and some piece of information, and then you retrieve those, pass it on to a machine learning model that's just gonna synthesize the answer. So just think about a system that you get a question, it gets a bunch of information, a bunch of books, it reads through those books and gives you the correct answer. Pretty much that's what RAG is supposed to be or is. Now, this is something that I'm genuinely dumbfounded that a lot of people do not know. So a lot of RAG systems today run pretty much by sending the query of the user directly to the RAG pipeline. But this is a mistake. You're spending a lot of money and resources doing this. Why? Anyone knows why? Any ideas? Okay, I'll tell you why. So it's simple. If every question that the user sends is a qualified question, then it would be a no-brainer. But as humans, even when you search Google, your first question is not the most accurate question you can send to the system. And because we anthropomorphize these systems, we might want to have a conversational-like experience with them. But it's not always, it doesn't always need to be grounded on some type of information. It could be something like you go to a system that is supposed to give you pretty much information about your company. A user unknowingly knows ChatGPT, goes to your platform and asks your platform, who is Miley Cyrus? Your system unknowingly just answers something incorrect because it's grounded on your company's information. So how do you mitigate this? You mitigate this with what I call a router. A router is pretty much a large language model capable of doing tool usage. So you can think about GPT-4, Claude, Cohere, and so on. So they pretty much made this very big. That's how agents work. And in a way, you can use it to do something very simple. This router is like a classifier. It takes the user's question and thinks, is this question related to the topic that I am supposed to pretty much be an expert in? If not, I'm going to answer directly. For example, no, I can only answer questions about company X or information about such and such. And this is the power of RAG and a router. Meaning, instead of you going through this system that has a vector database, embeddings, and an LLM call, you can just make that LLM call directly with some pretty much predefined answer. And this way you save a lot of money because you're not running this pretty much costly pipeline every single time. And all you need is just a model before your pipeline to create this workflow. You can create even more custom workflows. For example, if you wanted to search the internet, you just add another node here where it searches the internet and provides the answer. Okay, the second component that is crucial, and there was a research by Microsoft around this, is read. It's called rewrite, retrieve, and read. So how does this work? Imagine a conversation with the system. The first question that you might ask the system is probably unrelated, like on Google. Your first query is not gonna be the most optimized. It's after a couple of queries that you get pretty much the gist of what you should be searching for. So what you can do is use an LLM to read through the chat history. So for example, if you asked, your last question might be, what is this, right? You didn't specify what this is, but throughout the conversation, it's implied what this particular thing is. So with a system like this, you can have an LLM read through the chat history and rewrite the question. What is X? What is Y? With the actual keyword that's gonna help you do retrieval better and save you a lot of money. And on top of that, pretty much allow the user to get accurate answers. So you can do this up to N. There's no limit to how many times you can rewrite a query. I personally prefer 3. I think 3 is good enough if you have a model with large enough context. And with this, you retrieve way more documents than before. So instead of retrieving 10 documents, you can retrieve 50 documents that are similarly or closer to these queries, including the input query. And this provides you a better experience. And here is where an SLM is also important. So you can see that this here is a model that you can train to do something very simple. Take the history, rewrite the question in 3 different ways, 5 different ways, and so on and so forth. And the last one as well can be a very small model that is capable of not only providing the answer, but also providing, for example, identification. Where did this piece of information come from in the documents that it used? Then another pretty important component. So I'm talking about components here, and we will gather all of this into a single pretty much pipeline that you'll be able to see later on. But another component that is super relevant is a re-ranker. So how many are times that if you actually have a RAG system in production, a user asked the question and the first 5 documents were irrelevant, only the last 5 were super relevant. So a re-ranker can ensure that the information that needs to be at the top will always be at the top. So it will take all documents you retrieve from your vector database or your database and rank them according to how important it is to the particular question or questions that were asked. And here I think the best so far that I've seen is Cohere. Check them out. They have really good offers when it comes to this. And on top of that, you can do something called contextual compression. So after you re-rank, you take the documents and you can filter out by documents that are similar up to a threshold. So this way, you only return the 3 most important documents, not the 10 documents, but only the top 3 are like the most relevant. Now, looking at the pretty much high-level view of how this would look like if it was together. So you have here the user input. It goes through the router. If it's not important or relevant to the pretty much information that you offer, just pass it on to the LLM and provide a canned response, or have the LLM respond politely. Or if the information is relevant, you can now run your expensive pipeline to provide the most accurate information. And on top of this, this pipeline can be completely custom and built on open source. So you have here the trainable model, the model that rewrites the question. You have the re-ranker that is also a model that you can train with a little bit of information. And finally, you have this synthesizer model here, including this small model that provides canned answers. All of these models can be completely customized and created with open source. Any questions so far? Okay. Now, this section should have been called training and fine-tuning, but I'm going to call it machine learning experiments because this is something I've been testing out since the beginning of the year. It's what actually threw me into this trajectory. So in this section, I'm going to tell you about how you can create powerful small language models on a budget. So it all started with the misuse. The misuse was released around end of January or beginning of February. It's a model, as the name implies. The misuse is a Greek giant, the fastest Greek giant, and actually one of the smallest giants of all. And this is what kind of threw me into this idea of, wait, you can run a model with 2 billion parameters on a MacBook Air and provide experiences similar to a model that is 25 times its size. So when I created the misuse, it actually blew up. It had, at its peak, it reached around 4,000 monthly downloads. So that was, for me, a big indication that there is a need for this in the market. And on Twitter, it went semi-viral with 19,000 views. So how does the misuse compare with models across the landscape? Here's the base model that I used, which was Phi-2. And you can see that the misuse is significantly more performant than its base model, outperforms a model 1.5 times its size, and pretty much competes with a model 25 times its size. So it's punching up its weight class. It only has 2 billion parameters, but it's competing with a model with 70 billion parameters with a lot of funding. And I did this with less than $200. And here you can see kind of the previous information, but it reached around 4,000. Then before this, I had a previous series which was called Coding Llama 2 from scratch, where I was really interested in understanding how these models work from scratch. And because I have a background in machine learning, I thought, well, I could learn and also bring people alongside with me. So I created the first series, and then I stopped because I was busy with other things. And I was called out on Twitter, and someone said, hey, Prince, Llama 3 is out. Why don't you start a Llama 3 series? So there's a thread on Twitter where I described everything I was going to do throughout this series. And here's what I did. And you can find this on YouTube. So I created the world's first Llama 3 with 6 billion parameters. So this model is 33 times, it uses 33% less resources whilst having 70% plus performance of its original or source model, which was Llama 3 8B. And the technique that I used is called downcycling, where you take a model that is bigger, let's say Llama 3 8B, and then you cut off 2 billion parameters out of that original model, and then you create a new model and you continue to train that model on only 1 billion tokens. Llama 3 was trained on 15 trillion tokens. And Llama 3 6B was only trained on 1 billion tokens. A tiny fraction, not even 1% of what it was used to train Llama 3. And it achieves competitive performance as well. You can see here when it comes to reasoning, which is this benchmark here, GSM-Q8, it achieves more than 50% of the reasoning of the original model. And throughout, for example, for telling the truth, it's pretty much tied with its original model. When it comes to ARC, pretty much it has some challenging tasks. It's similar to the original model. HelloSwag and MMLU, it achieves significant performance. And this is using pretty much 33% less resources. This is the difference between 4 gigabytes of VRAM, which can be super expensive because you cannot find easily just extra 5, 10 gigabytes of VRAM. You'd need to pretty much get an entire machine to do this. And I did this with only $500, and I'll detail the costs in a bit. So let's look at this model with a bigger view. How does it sit and compete with its landscape? So you have here Yi 6B. It's a model with the same kind of parameters as Llama 3 6B. It's competitive, right? And Llama 3 6B outperforms Llama 2 with pretty much 2 times its size. And this was trained on less resources than Llama 2 13B was used, right? And what did it cost? It's simple. In total, we're around $792, out of which $20 were for storage. I needed a few terabytes of the storage to process the data set, save the model checkpoints throughout, and of course there are other costs involved here that are pretty much extra, but if you count it in total, it's about this much. When it comes to compute, out of the 771, for this particular experiment, I only spent 532.86 cents in dollars, of course, right? So you can do the same. And here's the funny thing. Someone reached out to me on LinkedIn, a director of AI at this company, and he said, Prince, I ran your same experiment. This experiment took 4 days for me to run. He said, I ran the same experiment that you ran in 24 hours, and I spent $350 only. I said, what? With $350, you managed to replicate my entire experiment? So you save about another 35% in costs, and you gain pretty much 80% in terms of performance, meaning instead of taking almost a week to train this model, it only trained within 24 hours. What are the benefits of this? The first one, and most important, like Maluk, it's cheap. The second one, it's scalable. Maluk is capable of carrying probably twice its size. It's a very powerful machine, and in this case, we have a very powerful experiment. And on top of that, like Maluk, it's very versatile. You can use it for any scenario. You're going for an important talk, put on a suit, and Maluk will take you there. You're going to school, want to look cool, like the kids in the 70s? Maluk is your guy. And in this case, you have the benefits of Maluk with the cost of a Maluk. And in some cases, as you can see, it can actually drink vodka at times. So $350 instead of 500. And with that, let's talk about a few, pretty much tie up everything. The first thing is modularity is key. As you saw in the RAG pipeline, you can pretty much stitch components together to create a custom workflow that serves your business individually, not someone else's, your business. It's optimized for you. Then you need to evaluate every single step. So is the router working correctly? Is the vector database working correctly? What can I do to make it better? Make sure that you are pretty much controlling all the metrics throughout the pipeline. Another thing is you can start with a large model or the best-in-class model like GPT-4, Claude 3 Opus to scope your use case, but then you can go and build a smaller language model, because small language models and great data is all you need. Thank you. Any questions?
Okay, I see one hand.
Yeah, a question regarding the training method, or rather the downcycling method. Could you go a little bit into more specifics of how you've cut out those parameters? Yeah.
Okay, that's a really good question. So I have a YouTube video about this where I dive deep into details. But at a high level, downcycling is you have a reference model, let's say Llama 3 8B, with 34 layers. Out of the 34 layers of Llama 3 8B, you cut off 24 layers. You use those 24 pre-trained layers. You fit it into a new model. And of course, you keep the structure. For example, the embedding layer, the language model head, the normalization layers. And then you take that model. Actually, that butchered model already works well. It does, of course, it has some problems with repeating information and etc. and loss of memory. For example, when I was running this experiment, it couldn't remember who created Python. But with pretty much continued pre-training with 1 billion tokens, it managed to recover all of that information, even where the Eiffel Tower is and everything else. And these are tests that I ran. Everything is open source, code, model, data, including my weights and biases logs. You can just check it out on YouTube, or on Twitter, you can follow me and check it out.
Okay,
and there's also a GitHub repo called Coding LLMs from Scratch that you can find through the videos.
Thanks.
Questions? I don't bite. Okay, another one. Magda, that side.
Okay. Could you please raise your hand again? Ah, okay, that's you.
Hi. For small models deployed on mobile devices or similar, what do you think is the possible context window number of tokens that we can process locally now and maybe in 1 or 2 years?
Right now, with about, let's say, iPhone 15 Pro, I'm not sure, but I think it has around 16 gigabytes of RAM. I'm not sure what are the limitations of the chip, but you could do, I think, 4,000 tokens on a small model, and probably a bit more if you quantize that model. Let's say you take a full precision model, quantize it to 4-bit, 2-bit, you might be able to achieve probably 10, 20,000 tokens. A context window in that case.
Any other questions?
Come on, guys. Bring the juicy questions. I know you're curious.
Okay.
There you go.
So many bags here. Oh.
Thanks for the great presentation. I have a question. Knowing that you're going to start your training, you're going to press a button and you're going to spend $500. How do you know that the hyperparameter you choose are going to be the good one and everything will be fine?
That's a really, really important and great question. So I used to work at Neptune AI. It's an experiment tracker. And what you do, I help a lot of companies, like thousands of companies do this. You don't just start your main run. You run smaller experiments, tweaking the hyperparameters. So you check if the learning rate is right. You check if the loss is going down. You check if the eval loss is also continuing to go down with, let's say, 100 steps. Then you commit to 1,000 steps or 1 to 2 epochs. So you first start running smaller experiments. I ran around 3 experiments, and if you look the video and the weights and biases, you'll see the charts where I have V0, V1, and then V2 was the one that I let it continue because I was already sure that it would work. Any other questions? Anyone?
1 minute left. Question?
This is the chance.
Okay, so if there are no more questions, I would like to thank you, Prince, for this energical presentation. And I'm sure that you will have some more questions now on or at after party. So thank you for being here. Thank you.